ionic product constant of a salt. What is this ionic product Ki of a salt is? See, it is very much similar to your KSP, which we have done just now, which is called the solubility product constant of salt. It is very much similar to this KSP. The only difference is KSP is the product of molar concentration of the ions raised to the power their number of ions obtained from the one molecule of the salt when they form a saturated solution, because it is involving the solubility. But what is this Ki is? It is again the product of the molar concentration of the ions of the salt raised to the power the number of ions given out by one molecule, but at any concentration. So what we simply write is Ki as it is KSP but at any concentration. At any concentration. You can clearly make out this Ki sometimes also called QSP also, because it's how this is your K equilibrium is and this is your reaction quotient is. So this is at any concentration. Now therefore, it is the Ki which decides when the precipitation will take place. If the Ki is greater than KSP, or as per some books here this QSP is greater than KSP, that means the product's ions concentration is more than the what they can have maximum at this saturated solution. What will happen is precipitation will take place, and if the Ki is less than or equal to KSP, or your QSP is less than equal to KSP, no precipitation will take place. So that is how this information is very valuable to us to determine when a precipitation will take place, or how much of quantities of the two different salt solutions or ion solutions is to be taken so that their precipitation will take place, or to prevent their precipitation they should be taken minimum of so much of concentration so that they should not form precipitates. So this is a very valuable information, and Ki, your ionic product constant, is the actual term which gives us the idea about the precipitation. Now let me give you an idea how we can express this Ki or your QSP. If it's a salt like AgCl, your Ki is also the product of Ag ions concentration and chloride ions concentration. It's very similar, no difference as per the KSP is concerned. Only thing is that it is its values which is going to make how it is different from your KSP term is. Now let it be, this thing can be made more clear by doing certain numericals. Now let us understand from a numerical how the solubility product constant KSP and the ionic product constant Ki are related, and how they help us to understand whether the precipitation will take place or not. The numerical is find whether precipitation will take place or not when 10 to the power minus 3 molar calcium chloride solution is mixed with 10 to the power minus 4 molar and sodium fluoride solution. The KSP, or the solubility constant of the calcium fluoride, is 10 to the power minus 12. See, we know when this calcium chloride and sodium fluoride will be mixed, it is going to form calcium fluoride which will be precipitated out, and its solubility product is this much. Now whether the precipitation will take place or not, we have to find out from whether the calcium ions and fluoride ions concentrations product is more than this or not. The calcium chloride is going to give us calcium ions. 10 to the power minus 3 molar calcium chloride will give us 10 to the power minus 3 molar calcium ions. 1 mole of calcium chloride contains 1 mole of calcium. Similarly, 1 mole of sodium fluoride contains 1 mole of fluoride, so 10 to the power minus 4 molar NaF will give us 10 to the power minus 4 molar fluoride ions concentration. And the calcium fluoride's expression for Ksp is calcium ions concentration, fluoride ions concentration square. So we have to make the square of the fluoride ions concentration. Now we know what is the concentration of your calcium ions and fluoride ions is. Now let us find out what is their Ki is. The Ki will be calcium ions concentration, fluoride ions concentration square. It will be 10 to the power minus 3, 10 to the power minus 4 square. So it will be 10 to the power minus 11. Now this, your Ki is greater than 10 to the power minus 12, which is actually is the Ksp of the calcium fluoride. Therefore, precipitation will take place and we will have calcium fluoride precipitates. So this is how this information is used to find out whether precipitation takes place or not.